And how many attempts does the practice test have
It's
for
got 10.
Okay.
Was there
Uh,
a way when you're doing the practice text in Alex that you can redo the whole thing and not just the ones that you missed? So you can kind of continue practicing even if it seems like you have it?
well, there is, but I have to assign it a second time and and put it for it's what they call a full retake. That's the only way to do it. It'll just be another, an extra assignment as a full retake.
Like I
But that
see when it asks you when you're done with it, do you want to do the full retake or just do the ones that you missed? But it still just gives you the ones that you missed. I don't know.
even
I don't know if
even
it's here.
even if you do full retake, it does.
Yeah. Yeah, I feel like it asks you some question like that. Maybe I'm wrong about what it asks you because it's been a few weeks, but I
Let me
feel like
just,
I clicked on that specifically last time.
well,
But I don't know.
as far as I
I'll keep
know, I
playing.
mean, there's only one or the other option. Let me just see. Yeah, retake options. So it's either full retake, students must retake all problems, quick retake, students only take incorrect problems. And probably at some point I did quick retake because somebody was complaining about, having to take the whole thing. So that's why. But I mean, if it gives you that option and it doesn't allow you, if you're doing it, then I don't know what else to do. I can't really change it now because it's over there. I just have to create a
I just
new one.
wasn't sure if
And
it was just me or if it was an option
well,
because it seemed like it was an
I,
option, but then it wasn't.
I don't know why I
No,
would
I
ask
don't
you.
want to do it for everybody if they don't want it, for sure.
I
I'll
don't know
make that
why.
decision for the rest of the.
I don't know why if would ask you if it were an option. That I can't figure out. Well, let's just go through each one of these. I was going through it last night with my other class. There's a couple in here that are repeated, but so we won't have time to go through all of them. But hopefully, if we're here Thursday, we can go over the whole thing because this one takes a little bit longer. Okay, this is one. It's just talking about outcomes. It talks about two students running for president, Marie and Linda. And then there are two students running for vice president. So there's a fork off there, two people, John and Bob. And then you got three running for treasurer. Now, by the counting principle, that's 2 times 2 is 4, 4 times 6. I'm sorry, 4 times 3 is 12. So there's 12 different options. So you can put a 12 right there. All right, and then you're going to just answer a couple of questions. How many outcomes have both Maria and Bob being chosen? Okay, that's going to be the only one that has Maria is the first 6. And then you can look at the ones that also have Bob. So I can't select them for some reason. I wish there was, but there's 3 of them right here. It's the second pair of 3. You see it? So there's 3, Maria and Bob. How many outcomes have Jessica or Amanda being chosen? Well, that's or. So as long as it's got one or the other, we're going to select. So here's a Jessica, here's an Amanda. So there's 2. Here's Jessica and there's Amanda. There's 2 more. That's 4. Here's another Jessica or Amanda. That's 6. And then 2 more. So that's 8 that have Jessica or Amanda. Mm-hmm.
They just sent an email. Delgado is like they're trying to see today if they're gonna have any classes for tomorrow.
Yeah. It may be only affecting tomorrow, but yeah, I've seen that. All right, so that's all they're doing is just about outcomes. They're not asking about probability yet. And this is the same kind of thing. It's talking about a numbered cube with faces labeled 1 to 6. Well, that's just a single die. Right. Thanks, Yuka. That's right. I don't know why it always picks those strange times. It says it's like I noticed that it's like 11:09 or something that it opens.
Yeah, it said like it was like 1 minute from when I typed that. I was
Yeah.
like, that's funny.
I don't understand how that's why I really don't want to change them, and that's why I got so many students now because all these extra they put more students in classes, and some people want me to change them, and they don't change right the way you think. Okay, so the sample space is just easily 1, 2, 3, 4, 5, and 6. And then what the event of greater than 3? Well, that's just 4, 5, and 6. Any questions about that? It's just asking for the sample space and then the number of the number of outcomes in the event. They don't ask for the probability, but they're going to start doing that. Because there was one section, 10.4, that just dealt with sample spaces. All right, so here we got the first one that talks about probabilities. But a coin is tossed 3 times. And so we're going to just have written as head, tail, and head, or tail, tail, tail. However, the 3 come about. Just one letter to represent. So there's 8 of each one because there's 2 each time. 2 times 2 is 4. 2 times 4 is 8. All right, so let's see. The event A says a tail on the first toss. So anything that's got a tail in spot 1, we can put. And that looks to be the only one that's got a tail in the first spot, right? 4 of them. All the rest of them have heads in the first. So this is 4 over 8. And I'm going to just write it like that first. Of course, they're going to want us to reduce it down. But that's 4 over 8, and that's 1/2. More tails than heads. So that would certainly describe this one. This has got 2 heads and 1 tail, so not that one. This has got 2 tails and 1 head, so that's good. It's got 3 heads. This has got 2 heads and 1 tail. 2 tails and 1 head. There's more tails than heads. This has got more tails than heads and tails in that one. So again, 1, 2, 3, 4. That's 4, 8. So that one is also 1/2. All right, so alternating tail and head with either coming first. Well, that's not alternating. This is not alternating. This one is not alternating. Here we got alternating, not alternating, not alternating, not alternating. So there's only 2 that's got tail, head, tail, or head, tail, head. All right, so that's 2 out of 8. But again, you always reduce your fractions for a final answer. So that's 1.
It says with either coming first, though.
What's that?
I misread the question. I said with either coming first, so I was counting the THH, but it's a full alternative. Nothing. Ignore me.
Okay. Yeah. So there we go. All right. So now we've got one that's going to deal with permutations and combinations. And we got 7 acts in a talent show. And this says acrobat, comedian, dancer, guitarist, juggler, magician, pianist. It's not so important what they are. It's the 7. And then you're going to have 4 that are going to be picked. All right? 4 that are going to be picked. So the first one is in any order. So that's the combinations. Event B, it says you got to have them in a specific order. Magician, comedian, acrobat, and juggler. So that's the permutations. So I'll write on the board what it looks like. So so this is the order, and this is no order. Well, actually, I got them backwards. It was the first one was without order. And this was any order, it said. And that's really saying the same thing as we don't care about the order. The order is not important. Not important to us. So we could do that by hand if you want to. You got that? If you got that TI, whatever it is, SX2 thing, this does it. But I'm just going to work use the calculator here.
840, I think.
35. And then the next one is ordered. So this is the one that's going to be permutations. And this is going to be a larger number because of the fact that ordered, you're going to have more. You're going to have a factor of 4 factorial, which is 6 times 4, 24 more. It's actually good. We could just take this and multiply it by 24 if we wanted to. But to be safe, you work it out. $840. And as I said, is the number that the difference in these two. This C has got an extra 4 factorial down there in the denominator, which is 24. So if you take 35 times 24, you get the 840. So if you get good at it, you can kind of take advantage of those little things. All right, so this one was in any order. So this is the 35, and then this is the 840. Oops, you know what? I'm sorry. It's probability. So it's 1 over. I had one like this in the notes. It was about like with people with J names. Same one. All right, so this one is the first one that deals with odds and probability. Remember that we can go back and forth from odds to probability, but they're not exactly the same thing. All right, it says Charmaine has a box of candies with different flavors. She will randomly choose one piece of candy. The probability that she chooses a strawberry flavored piece is 6/19. What are the odds against her choosing a strawberry flowered piece? Now, remember that when we're dealing with probability, there's a probability of something happening, and then there's its complement of 1 minus its probability. So what would be the probability of not getting a chocolate candy? If this is the probability of getting it's strawberry. If this is the probability of getting a strawberry, what's the probability of not getting a strawberry? Well, I'll just put an S here. And then I'll just put S complement like that. So 6 from 19 is 13, right? Because the probability of something happening and it not happening have to add up to 1. So 6 plus 13 gives us 19. So there's what we've got, our complement. Now, it was odds against that they wanted. Find the odds against. See if I can write this out where it looks nice. Let's see. So odds against the number of losses or the numerator of the losses. So it's going to be like this. It's messy to write it out formally, but it's going to be 13, 19, colon, 6, 19. But once you simplify it, the 19s go away. So it's just 13 to 6. So it's 13 to 6. And again, you can go back to the probabilities because the 13 and the 6 add up to be the 19. So what this essentially means that out of 19 trials, 13 of them are not strawberry, 6 of them are. And when you're talking about odds against, the number of not strawberries is going first. And then this is the number of strawberries. So this one is giving us the odds in favor, okay? And I really don't like and I like writing odds like this or like this. I don't like writing them as a fraction because then it looks like a probability. It's easy to get confused like that. So in a certain board game, a player spin a spinner to determine how many spaces they advance. The odds in favor of advancing 5 spaces are 3/10. All right. Or in other words, it's 3 to 10. Write it. In this case, it's 3 to 10. All right. And that is what it said, isn't it? Yes. Now, that means that the denominator of probability, and what was it it wanted? It wanted probability of, find the probability of advancing. We'll just put A. So down here, is 3 plus 10. Now, since this is odds in favor of advancing, then that's the number we're going to put right here because we want the probability of advancing. And this one is rightly written as a fraction, 3 over 13. All right, any questions about it?
That one's definitely the one that I just understand the least. I'm
Well,
not sure where my disconnect is.
okay, it's odds in favor. And like I said, I would, since it says odds, them writing it as a fraction kind of hazes it a little bit. So rightly, I would write it as 3 colon 10 or 3 to 10. So that way we're sure that we know that it's an odds. Now, the denominator has to be those two numbers added up, 3 plus 10.
Okay.
Because
it's like the last one, but just in reverse. But for some reason, I just can't do it in reverse.
Yeah. Well, it is. It's because you go everything when you go backwards is always like that. All right. So
I guess backwards, it's still 19 instead of becoming 10 to 13. I think that's what keeps throwing me off.
That's a whole different scenario, though. See, if they had used the same scenario with the strawberry candy, you might be able to see it, a little bit better. But this is a whole different one. This is one with a spinner, and so the odds in favor of advancing are 3 to 10. So the denominator has to be the sum of 3 and 10, which is 13. Now, since this is odds in favor, and we want the probability of advancing, then odds in favor, that's what that 3 is. The first number in the odds, when we got it odds in favor, is the numerator for advancing. Like I said, is you can also look at it if it odds in favor. When you got that first number, the 3 is the numerator for probability of success is another way of putting it. If it had said odds against here, then the 10 would be the number we'd put up there. All right. Because then in that case, they're turned around. Odds in favor and odds against are flip-flopped. Well, think about it a bit. If you got another question, I think we've got another one coming up on this. I think this second one is the same kind of thing. Yeah. All right. So Melissa is at a grand opening celebration of a supermarket. She wins a wheel. She spins a wheel with 10 equal size slices as shown below. The wheel has 7 black slices, 2 gray slices, and 1 white slices. So it has 10 slices, equal size. So the probability of landing on any one circle is going to be 1/10. When the wheel is spun, the arrow stops at a slice at random. If the arrow stops on the border of 2 slices, then it's a no-go. You just spin again. If the arrow stops on a black slice, then Melissa wins, and she gets a gift card. All right. So I really wish I could write up here, but I have to go to the board so you can still see it. If the arrow stops on a black slice, she wins. So in other words, if it's on this one, 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 which is how many? There's 7 over 10 is the probability of winning. Let me write that down over here. And I'm just going to put when here. I mean, it's black. So it's 7/10. Write it out. I hate writing fractions like that. They're kind of confusing. All right. So in that case, the probability of losing is what? 7 from 10 is 3. And we know that that's correct because 7 and 3 add up to be 10. So 7/10 plus 3/10 would give us 10/10, 10/10. So that would be 1. Okay. Does that make sense? All right. So there's two things, and I can't remember which. Do you remember which one it was? It's odds in favor. We'll put both of them. All right. So we see that. Okay. So what was it wanted? It wanted odds in favor. So it wanted 7-3. All right. And so if the arrow stops on a black slice, then Melissa wins a gift card. So it's talking about the same scenario. So find the odds against. Well, simply just turn them around. Does that make sense? Now, if we wanted to, we could add those two up, the 7 and 3, in either case, and we would get 10. That's the denominator of the probability. And so, since this is odds in favor, 7/10 is what we originally had for the probability of winning by landing on that black circle. And then the 3 would be the probability of not winning, the 3/10. So does that make it a little bit clearer here? Again, they didn't ask for the for going backwards with the probability and the odds, but I tried to fill in the blank there for you. All right, so this is an expected value problem, and really we probably need to draw out a little thing on here on the board. So I'm going to draw out a little, I'll draw it out right here below this one. All right, we got, let's see, how many things were there? All right, so it's 1 through 6. And then I got to have a, so I need one, so one for label. One, two, three, four, five, 6. Oh, I'll just have an extra one. All right. All right. So this is going to be this is the X, and this is the probability of X. And I guess we could just say it's kind of hard to put it here because I didn't leave enough room, but this is the outcome. I'll just try to scribble it in there. In other words, those are the 1, 2, 3, 4. All right. Now, what we're going to put now for X is what happens when each one of those things happens. So this is $1, one single dollar. For number 2, it's $3. This is $5. $7. And then for the last 2, I think those are both losers. Yeah. These are both 125 negative. All right. Now, this is just a standard die. It's a 6-sided die. So each one of these is 1/6. Was a die? Yeah, well, it's a spinner, but same problem, same idea. Okay, does everything up to that point make sense? Those are all 1/6. That's essentially the setup of the things you really need, and it really helps to have a table to do this. All right. Now what I'm going to put right here is X times P of X. I'm going to multiply those 2 rows. And I'm going to leave off the $sign for now, just to make it easier. So 1 times 1/6 is 1/6. 3 times 1/6 is 3/6. 5 times 1/6 is 5/6. Seven times 1/6 is 7/6. Let's see, and then this one is weird because it's got a quarter in it. Let's see how we can write that. All right, I'm going to put it in the calculator, and then it's 1.25 over 1. and then times 1/6. Tell you what, I'm just gonna write it like this for right now. It's not a formal fraction, but we'll straighten it out in the. All right, and it was negative 1.25. All right, so what I'm going to do is I'm going to add all of the positive ones up. So that's 3, 4. So it's 16/6. So that's all of these here. Right there. Numerator's all up to 16/6. And then this is both negative. So that's 2.5/6. And so 16 minus 2.5 is 13.5/6, and it's positive because this negative is smaller than that one. So when you divide by 6, you get put it back with the dollars now. $2.25. All right. Do you see anything that I didn't do right? As far as I tell, it all looks good. I'm going to go back over just to make sure. Let's see. $1 on 1, $3 on 2, $5 on 3, $7 on 4, and negative 1.25 on 5 and 6. All the probabilities are 1/6. Multiplying 1 times 1/6 is 1/6. 3 times 1/6 is 3/6. 5 times 1/6 is 5/6. 7 times 1/6 is 7/6. Then you add all of the positive ones up, you get 16/6. The two negative ones, because they're losses, is negative 2.5/6, because when you add 1 1/4 to 1 1/4, you get negative 2.5. So that's 13.5/6 positive. So this is what we call an expected value of $2.25. So $2.25. Now, since it's positive, Joe can expect to gain money with 2 per spin. If it were negative, it would be lose money. If it came out to be 0, then it would be break even. Okay, any questions about that one? I know that one's a major pain in the neck. There's another one in here like it. Or there's another expected value problem in here. So if you're not entirely clear, we got that one now. All right. So MotoWin Auto Superstore is thinking about offering a 2-year limited warranty for $915 on all new car of a certain model. The terms of the warranty would be that Moto Wind would replace the car free of charge under certain specific conditions. Replacing the car in this way would cost Moto Wind $15,700. Suppose that under the warranty, there's a 6% chance that Moto Wind would have to replace the car one time and a 94% chance they would have to replace the car. All right. So this one is just going to be two different outcomes. I'm just going to put here, car is good. If you don't make that little thing big enough, it wraps. Car bad. Only two things is going to happen. So this is X. Probability of X. Now they give us the probabilities there. So let's start with those. It says 6% chance would have to replace. So here's the 6%. And then the 94% not replace. So that's supposed to, in both of those cases, are supposed to be a decimal. You got to write as a decimal. You know, you can't really do calculations with a percent. All right. Now, what happens if the car is good? What do they get? Because this is from the perspective of Moto Wind. It's perspective of the company. If the car is good,
They got $915.
yeah, they got you $915. Now, they're telling you here that replacing the car would cost them. So there's nothing net here to work about. In other words, sometimes you may have to calculate net winnings, just like you might have to calculate the probability. So here, 15,700 is just going to be a negative amount. There's no, they said that's how much it's going to cost them. We don't know how much they pay for the car. And that's not really a matter of importance. So now, down here, it's going to be X. All right, so let's just calculate this out. 915. So that's $860, 860.10. So again, that's dollars. And then the other one is 15,700 times 0.06. So this is negative all right. So now E is equal to, or the expected value is it looks like this is going to be a lose situation. Because this would be negative $82. So it's negative. See, that's that little negative sign in front. So that's an expected loss. So let's go back to the so since it was negative $82, they can expect to lose $82.
Mr. Cruz, I woke up late.
Okay.
I know you don't care. I'm just letting you know I'm here.
Okay. Well, I'm reviewing, so I was thought people had questions about this.
I'm gonna go look at it when I get to my job. That's when I look at do my homework. I'll be sitting down, so I'll go back and look at the conference call.
Okay. So negative $82 means that it's a loss. All right.
Are we rounding it?
Well, there was nothing around. It was just 82, wasn't it?
81.9.
Oh, it was? Oh, I must have made the calculation wrong. Let me do it again. Oh, you're right. I'm sorry.
10 cents.
I'm sorry. Let me go ahead. No, you're right. I was just drifted out a bit. You're right. So it's 860. Let me make sure. 0.1 minus 942. You're right. $81 and but no, they don't ask you to round it. So you're right. I just left it off when I was doing the calculation. So negative. So let's go back over there and fix it. All right, let's see what else we got. We're getting into about halfway. If we can do that, we should be good to finish on Thursday. If for some reason, class is affected, what I'll do is I'll get on and I'll work the second half of this and then put it on there, just like you would usually be able to go in and look at it, okay? I mean, unless something really bad happens, I doubt that they'll close Thursday, but looks like it'll just be tomorrow, even if it does affect us. All right, so this one's a Venn diagram, and this one relates very closely to chapter 2, when we talked about the number of elements in the union, because if you remember, we used a very similar formula to find the number of elements in the union. We just did it with the counts rather than the probabilities. Well, it works the same way. So let's just go through and look at this. All right. The Venn diagram below shows the 9 students in Mr. Campbell's class. The diagram shows the memberships of the science club and the music club. All right. So he's got these folks plus this lady in his class, Rachel. Note that Rachel's outside since she's not a member of either club, but she's in this class. All right. So one student is selected randomly, and A is the student is in the science club, B is the student is in the music club. So A is science club, so there's 1, 2, 3, 4, 5, 6, 7, and there's 9 total, right? Does that make sense? B is music, so there's 1, 2, 3, 4 over the total of 9, and we don't have to simplify any of these. They're already simplified because of that 9 makes it. It would have to be a factor of 3 to do this. Now, and remember, that's the what we call the intersection. So that's 3 over 9. And I'm going to leave it just like this briefly, just to let you see the effect here. Now, we can do this 2 ways. We can go and count all of these, 1, 2, 3, 4, 5, 6, 7, 8. And again, I'm not going to, so we can just count them, or we can use the formula. 7 ninths plus 4 ninths. And the way we would have done it in chapter 2 is we would just be using the numerators. 7 plus 4, which is 11, minus 3 gives us 8. So either way gets us to the same spot. And then I'm going to put this one because it's got to be simplified. All answers need to be simplified. So this right here is the formula for the probability of A or B. Because that's what these both, well, these are both the same thing. Questions on that? All right, any questions about that?
So the A or B
Mm-hmm.
is going to be all of them,
Yeah,
including
it's all. Including what?
including like the middle.
Yeah.
Okay.
You remember in chapter 2 they would specifically tell you that they're in A or B or both. They don't have this is the one, this book makes a habit of doing that. But when you're saying an A or B and you're talking about the inclusive or, it does include both. So yes, because you have to just ask yourself, hold on a second, let me finish. Is Javante out there? I don't see him. So Nathan, Lena, Kenya, I don't see. Sorry, Kenya, yeah, and then Jalen, I don't see. All right, so let's go back to that. So what you got to ask yourself in the case of these three right here, are these right here, is Melissa in science or music? Is LaShonda in science or music? Is Miguel in science or music? Well, yes, they are. They're in both of them, but they are in what we call the union as far as, yeah, I got you, Evelyn. I'd already done it. I usually do it at the beginning and then I do it in the middle for anybody that comes in. So people that here at the beginning, you know, they already on there. I was just doing the ones I wasn't sure about. Okay, and you just got to remember, in this class, the attendance really doesn't mean anything. It doesn't ever lower your grade, because I don't use it in the calculations. It's just that I keep track of it because Delgado wants me to. You know, we're at what they call an attendance. I don't know what there's a name for it. One semester, or maybe it was a year, I think. Remember, we went to being, because that never does do attendance. So we went to be like that. And then this went for like a semester and then we went back. I don't understand it, but they want us to do it. All right. So rolling this is an 8-sided die, whatever that looks like. And so a number greater than 4. So it would be these 4, right? I'm just going to do them, click them all in and come back and do the probabilities. Rolling an even number, 2, 4, 6, and 8. An A or B. In other words, A or B means as long as there's a mark in one or the other or both, and then and means that it's in both A and B. So it's only those two. So let's go back and look at this. So this is 4/8, which is 1/2. Well, I'm going to leave them like that, and I'm going to come back and change them. This is also 4/8. All right. This one is 2/8. Now, they're going to ask us down there to fill this in. And I'm going to show you that again, how the formula works. So 4/8 plus 4/8 is 8/8 minus 2/8 is 6/8. All right. So that's this formula. That's doing it by the formula, or you can count them. Both work. Now we got to go back and change them to simplify it. It's 1/2. It's just that it works easier to do the math when you got them all the same denominator. So then again, this is going to be 3/4. Same as right up there. Because we did it both ways. So this right here, again, it's the same thing that we looked at the last one. That's the probability of A or B. Okay. Let's see if we got another time for another one. Some of these towards the end, we get a little bit time. All right, any questions about this one? All right, so this one is going to take a little bit of math, so I'm going to write it on the board and then work it out. All right, a TV studio has brought in 9 boy kittens and 6 girl kittens for a cat food commercial. The director is going to choose 7 of these kittens at random. All right. So that's 15 cats, right? 9 and 6 is 15, and they're going to choose 7 of them. What is the probability that the director chooses 5 boy kittens and 2 girl kittens? It doesn't let you copy the numbers. All right. Let's see, it was 5 boys, 2 girls. All right, and this is important here, this and, okay? All right. So this is what it looks like. First of all, we got 15 that we're choosing from. $15 cats, and maybe they put them in a box and pull out, how many was it? 7. So that 7, the combination of 7 and the 15, that's the total number of ways we can pull out those 7 cats. Now the and is essentially the multiplication rule. So we're going to have 2 separate ones here. We want to get 5 boys, and we're going to get, that's just terrible C. And we want to get 2 girls. Now I need to go back over and look how many boys there are total. There was 9 boys and 6 girls. All right. So any questions about how that's set up? Because that's what's going to give us. So let me go ahead and I'll do the calculations off screen here. All right. So, oh, you know what? This one's got the little thing here. I could actually, if I was a little bit more familiar with this, calculator, I could probably use this thing to do the whole thing. Let's see. Let's try it. Well, I hate to do that though. There's a way to do it. All right, but what I'm going to do first of all is I'm going to do the it was the 7. So it was 15 to choose from, right? And this is the total number of ways to pick the cats. So 6, 4, 3, 5. I'm going to write these down and I'll go back. So that's our denominator. All right. So for the boys, it was 5 into 9. So there's 126 for the boys. 126 ways to pick the boys. And like I said, I think if you use the parentheses and all that, you could have it do the whole thing for you in one whomp. And we could do that if we had time to check it, but I'm not gonna worry about that. And so there's 6 girls, and we're gonna pick 2. 15. All right, so let's just go back over to the board and do it. So then it's and then when you multiply the 126 by 15, it's 1890. And you'll notice, like all probabilities, if we did this right, the numerator is smaller than the denominator. And then if we divide that, it's, I think they said 3 decimal places, 0.294. It's the 9. Terrible 9, but that's 294. All right, so that's plenty for today.